What are Isaac Newton's three laws?
Newton's first law is the law of inertia. An object is set on a skateboard and a force is causing it to move. Then the skateboard hits a barrier, causing the skateboard to stop moving, but the object keeps moving because of inertia.
Newton's second law is F equals ma, also known as force equals mass times acceleration. An object is put on a skateboard and then pushed with low force.
As you can see, having a low force will result in having a mass, thus having less acceleration.
After that, the same object is put on the skateboard and pushed with more force.
Having more force will result in a mass having more acceleration.
A heavy object is put on a skateboard and pushed with force.
Skateboard does not have as much as the acceleration because it has a heavier mass.
Next, a light object is put on a skateboard and pushed with the same amount of force as in the first test.
Board has a higher acceleration because its mass is now lighter.
As a spring is compressed, it exerts a force in the direction opposite to that from which the first force is being applied. The work done to exert this force is caused by the conversion of potential elastic energy into kinetic energy during compression, which, in the case of a spring, is present due to its particularly strong tendency to return to a normal state. The act of overcoming the ever-increasing kinetic energy produced in the opposite direction requires the exertion of a positive net force towards the spring. However, if a force were to be applied such that the net force of the system was zero, the spring would remain in a compressed state. Despite remaining suspended in compressed state, there are two different opposing forces involved in the system of interest: the elastic energy of the spring, A, and an external force, the object compressing the spring, B. The dynamic between these forces when in suspended state serves as a clear example of Newton's third law of equal and opposite reaction, as the force of one object is of the same magnitude as the other, yet in the opposite direction. As the system of interest serves as a direct indication of net force, in this case the balance or equality of two opposing forces.
Congratulations, you now know Newton's three laws.